In this presentation, I'm going to explore some of the possible causes of efflorescence on roof tiles and how best to design the roof to eliminate or at least reduce the risk of it occurring. In the last few years, a trend has emerged where efflorescence forms on the underside of roof tiles and then runs down the top surface of the tiles below, giving the streaky appearance you can see in these photographs. Sometimes efflorescence can form on the underside of the ridges and then run down the tiles, as can be seen here. Like many concrete tiles, Condron concrete tiles are coated on their top surface during the manufacture to reduce the risk of efflorescence, but due to the method of manufacture, the tiles are not coated on the underneath, as you can see on this tile here. Tiles have been made this way for as long as I can remember without any problems, so why is it that efflorescence is now forming on the undersides? One theory, gaining some traction, is that the large volumes of water vapour passing through the permeable underlay, particularly during a new building's drying out period, condenses on the undersides and draws the natural salts out of the tiles. The internal climate of the building also plays a part. See here how the efflorescence is only on one side of a pair of semis, even though the roof tiles came from the same batch and were installed at the same times, perhaps indicating that there is more moisture being generated by the occupants in the left-hand house. To try to better understand this problem, let us firstly have a look at some common roof constructions. This screen shows a cold loft space with insulation laid horizontally over the ceiling. There is no eaves or ridge ventilation, so any water vapour making its way from the warm living rooms into the cold loft space will transfer out through the permeable underlay. This is a typical warm roof construction where the insulation is laid parallel to the rafters, usually fitted in between the rafters or on top or both. As with the previous screen, water vapour will transfer out of the structure through the underlay. This is a typical roof build-up. The underlay is draped horizontally over the rafters with a small drape between each rafter to allow any water to pass under the tile battens. Depending on the type of underlay, each lap may be sealed as shown here. The tile battens are then fixed into the rafters directly over the underlay. The underlay drape is important. Without a drape, any water present in the batten cavity, which is either driven through the tiling or from condensation, will be trapped behind the battens and then find its way through the batten nail holes in the underlay. This is the same roof shown in section. The underlay is laid directly over the rafters, and the tile battens and tiles are fixed directly over the underlay. Water vapour passes through the underlay and ends up in the batten cavity. That's the space between the underlay and roof tiles. The only way for the moisture to escape the batten cavity is through the gaps around the tiles. Concrete tiles are generally considered to be sufficiently air open to allow vapour to dissipate out into the atmosphere, though increasing cases of efflorescence on the backs of concrete tiles perhaps indicating that relying on the tiles alone to dissipate water vapour may not be enough. So how can we design roofs to reduce this risk of excessive amounts of water vapour and ultimately condensation in the batten cavity? One option is to provide traditional eaves and ridge ventilation into the roof space as shown here. This will certainly drive out much of the water vapour out of the roof space before it can pass through the underlay and enter into the batten cavity, though some vapour will still pass through the underlay. Many new roofs are installed with the dry ridge system anyway, so it's just a matter of leaving a gap in the underlay at the ridge. Air is pulled into the roof space through the eaves vents by air passing over the ridge, drawing air and water vapour out of the roof space. Providing ventilation may not be so practical in a warm roof structure, where there is no gap between the insulation and underlay. We now have some extremely efficient vapour permeable and air permeable underlays. These are very good at preventing condensation forming within the roof or loft space and enable roof structures to be designed with less or even without traditional ventilation, which makes for a far more thermally efficient roof system. Therefore, adding extra ventilation when the underlay is capable of controlling condensation may not be desirable. So what else can we do to overcome the problem of excessive condensation in the batten cavity? An alternative option is to install counterbattens over the underlay and vent the batten cavity. Starting with the rafters, we firstly lay the underlay over the rafters. This time we don't need to worry about draping the underlay between the rafters. Next, we fit nail tape and counterbattens directly over the rafters. The nail tape seals the nail holes through the underlay, and the counterbattens provide a gap for any water to run down the underlay, as well as an air path from eave to ridge. Then we can fix the tile battens over the counterbattens. This is the same roof shown in section. The underlay is laid directly over the rafters. Then the nail tape and counterbattens are fixed over the underlay. The tile battens and tiles are then fixed over the counterbattens. Water vapour entering the batten cavity through the underlay can still be removed through the tiling, but now, with the addition of the counterbattens, greater airflow can be promoted through the batten cavity by installing ventilation at eaves and ridge. Because the ventilation path is above the underlay, it does not compromise the thermal efficiency of the insulation. Depending upon the type of underlay, it may be necessary to cut back the underlay at the ridge to provide roof space ventilation. If this is the case, then the dry ridge system will ventilate both the roof space and the batten cavity. A dry ridge system will take care of the batten cavity ventilation at ridge, but to provide an efficient airflow through the batten cavity to remove the unwanted water vapour, we need to install an eaves vent. Standard overfascia vents are suitable for this purpose. Normally they are fitted under the underlay and support tray to vent the roof space, but for our purposes we can install the vent over the underlay and support tray. That way it is venting into the batten cavity. Just a word on extensions. Lean-to extensions to dwellings can be a problem, particularly kitchen extensions where a lot of water vapour can be generated from the kitchen. A common construction has a sloping ceiling with the insulation between the rafters with no space for traditional roof space ventilation. In this case, an eave vent can be fitted over the underlay and support tray with a top abutment vent fitted at the top junction with the wall. Very often, the height of the extension roof is limited due to the upstairs windows in a house. Therefore, there can be a reluctance to fit counterbattens, but these only need to be 15mm deep to be effective. In summary then, installing counterbattens with nail tape is a cost-effective approach that will not only reduce the risk of excessive condensation forming on the underside of the tiles, which can lead to efflorescence forming. Counterbattens also improve the water tightness of the underlay by protecting the nail holes, particularly important at low roof pitches. To promote airflow through the batten cavity, the ideal solution is a dry ridge system with eaves ventilation fitted over the underlay and underlay support tray. Traditional roof space ventilation will remove the water vapour from the roof space and reduce the risk of efflorescence on the tiles, but depending on the type of underlay, it may not be recommended by the underlay manufacturer, and it will reduce the thermal efficiency of the roof insulation. Manufacturers of air permeable underlays do not recommend that the underlay be cut back at the ridge. There is also the disadvantage that leaving an open gap at the ridge means the building is not watertight during construction until the roof covering, complete with the ridges, is fully installed, meaning further delays for the internal trades.